couple of things I want to get to there. Like that. So I'm basically going to ask you, this is your 5 homework. This is what we've already kind of done examples for. So let's see how we are. This won't be until next Monday. So by then we'll start by 2 by 3, so it's like they have like first of all, you'll see these kinds of directions all the time. Show appropriate work to receive credit, correct answers not enough, work must work the answer. Simplify, reduce answers to the lowest terms, only use decimal answers when directions say so, and then down appropriate. Write the solution in the given space when provided. So for instance, first question then. There are following angle measures from degrees to exact radians. When you see the word exact, that means no decimals. Leave the answer in terms of pi. So don't put in 3.14159 or anything close to that 22 over 7. Don't plug in any approximation of pi. Just be particular pi. So in terms of pi, there are 150 degrees into degrees. So you have degrees. You want radians. Degrees are basically your numerator. You want radians to be the numerator. It's about either memorized formulas. Okay. We know that there are pi. There's 180 degrees for every pi radian. And so what does that mean? Oh, okay. If I divide by 180, so 1 degree, I multiply pi over 180, that'll be radians. And then if I want 1 radian, I have to divide this side by pi. So 180 degrees divided by pi would be what I would get to get 1 radian. But again, which one do I use? That's where people struggle. So they just kind of guess. You have degrees in the numerator, you want radians only. So if you have degrees in the numerator, that means you're going to divide by degrees. Degrees go down here, and you want radians in the numerator up there. So the degrees reduce, and all you have are radians left over. And the conversion is there are pi radians in every 180 degrees. These are memorized things, and they're really good, so you know exactly what to do every time and which one to use. Think. So this is 115 over 180, the degree reduced, over 180 times pi radians. Now, if you stop there, you lose points because it's not simplified. You got to reduce the little terms. So I'm looking at that 5. This is 5 times 23. And this is 5 times 36. And then times pi radians. The pi radians. And so this is equivalent to 23. You can say 23 pi over 36 in radians. Or you could write 23 over 36 times pi. Now, if you don't put radians I'm okay with that because radius technically is not theta, but because you are converting to radius, it's not a bad thing to just happen. Here's where your penmanship and your writing matter. You gotta be real careful. It's 115 over 100 times pi over 1. So the pi would be in the numerator, or the fraction times a pi like it's in front of the pi. If you're lazy and you go 23 over 36 pi, that looks like pi in the denominator. Because that's what you wrote. That is exactly what I see. And I can only grade what I see that you wrote. I'm not going to go by your house and call you up or write you an email every time I can't read what you wrote or did you mean to put. I can only grade what you communicate to me. If you write 23 over 36 and that 5 looks like it's so, down there below, that's not right. It's not wrong. It's not correct. It's not right. It's a bad thing to do, but it's also not a correct thing. Details matter. Now, if you look, write final solutions in the given space, do not provide you one. There is no final place to write the final answer. So there's my answer. I can circle it or put a box around it. You don't have to if one is neat. The easier it is for me to find what you have, the nicer things go. But write final solutions in a given space when provided on the next question. Find the exact length of the arc on a circle with a radius r intercepted by eccentric angle theta. These answers in terms of pi. Down here, that's equals. So this is what I mean by when I provide you with given spot. It's the final answer down here. There's two formulas for arc. Two formulas for arc. The one that you now know from last week, if theta in radius, then the arc length S is just equal to R times theta. But theta has to be in radius. Theta has to be given in radius. The radius times the angular radius. Theta in degrees. Then arc length S, remember, it's a fraction of the whole circumference. Fraction of the whole circumference. So that means theta in degrees out of 360 total degrees. That's how you get the fraction of the circle. 120 degrees is 1/3 of the whole circle. So 120 over 360 will give you 1/3 times the circumference, and the circumference is times 2 pi r. So what matters is, are you given theta in radians or are you given theta in degrees? So on that question over there, you have a radius of 7 centimeters. Theta is 8 pi over 9, and we have to figure out the arc length. So theta is that radius or degrees? Radius. How do you know? There's no good reason. Not because there's a pi. You could have 8 pi over 9 degrees. if I had the degree symbol. That's how you know the difference. If it's degrees, it has to have the degree symbol. If there's no units, that's theta degree. Theta is degree. So that means I need to isolate purple as equals R times theta. R7 times 8 pi over 9. And 7 times 8 over 9, nothing reduces. 7 and 9 doesn't reduce, 8 over 9 doesn't reduce. This is 56 pi over 9. Now, again, this is where I left this spot, computer. If you draw a circle around that, with a happy face next to that, you said, look here. You lose a point because you didn't put it over here. Final answer, 56 pi. You also are going to lose a point if you don't have the right units. It's arc unit length. So what would the units of this arc length? So these are, and if you actually plug the unit in, plug in your stuff, 7 centimeters. This has no unit. That has to be 8 pi over 9. So the only units you will plug together is just centimeters. Over here, degrees over degrees, the degree units reduce out. You're just going to have a fraction, and then this is going to be 2's a number, 5's a number, and the only unit we have is the length of the radius. Have is just whatever. It's one dimensional, so like perfect. And then two questions. Now, remember, quizzes are open notes. Okay, well, you have open whatever you want to have open. You just can't be on the internet asking Dr. Matt. Right? You have to do the problem. You can have this out. The last question I have here is your bonus question. So this time we're finding the length of the radius. We want the length of the radius if we know the measure of the central angle. And the central angle is in degrees. I will see some, hopefully not, but I might, because we're going to plant this seed in there. Self-fulfilling prophecy. It's given in degrees, but some of you are going to use the radian formula and plug degrees into radians instead. That won't work. Now, you could convert 80 degrees into radians, then that's perfectly fine. If you convert it into radians, if you want to do that, that works. Or, it's open, no quiz, you have a formula, the degree formula. But what about a test? No notes on a test. I'm going to have to say memorize? No. Remember, arc length is just a fraction of the circle's circumference. That's what arc length is. It's a piece of the circle. It's a fraction of the circle. And the fraction of the circle is made by taking your central length in degrees out of 360 degrees times the circumference. We have three variables: arc length S, central angle theta, and the radius r. If you're trying to solve something with three variables, you have to have two of them, plug them in, and you then figure out the third. So I'm told that that's don't put that on the test. Well, 0.9. Okay. And that's going to be inch on your right now. Here it is. Let's look at it. Solving for the radius. What units for that? But inches, because it's a length. I never turned this off last class. It's going to be inches. So wait. Because it's a length. Radius is a length. Okay. 12.9 equals, I got 80 degrees out of 360 degrees. And I'm solving for r. So 2 pi, and I don't know what r is. Now, before you go start reducing things, or sorry, before you start solving things, I'm going to reduce that right side. If I can, I'm going to reduce. 12.9 is equal to, well, 2 goes into 360. This is now over 180 in degrees. I just reduced the 2 because it was quick. But so it's easier to be seen. I'm going to write what I still have. I have 80 times pi times r in the numerator and 180 degrees in the denominator. So now 80 and 180, you could divide by 10, but technically you could also divide by 20. 10 goes into it and they're also still even. You can divide by 20. 20 goes into this 4 times. 4 times 20. Uh-oh. And 4 times 45. And so we're left with 20 over 45. 20 pi r over 45. And we can still reduce by 5. Five goes into this 4 times, 5 goes into this 9 times. So I end up with 12.9 is equal to 4 times pi times r over a 9. And you could have just solved what you had to begin with. I like simplifying so I have less to punch into the calculator. The smaller the numbers are for me to plug in, the less chance my fat finger is going to press the button wrong. Rewrite this over here, one more room. All right. I want to know what r is. R is being multiplied by 4 n times pi. So I have to divide both sides by 4 and pi. It's being multiplied by 4 times pi, so I got to divide both sides by 4 and pi. R is being divided by 9. Being divided by 9, so I got to multiply both sides by 9. In other words, look at the fraction in front of your r. 4 pi over 9. So basically, I'm dividing both sides by 4 pi over 9. I'm dividing both sides by 4 pi over 9. And if you divide, that means you're going to multiply by the reciprocal of 4 pi over 9, which is 9 over 4 pi. When you divide fractions, you multiply by the reciprocal. So in the numerator, these are going to get multiplied. Nine times 12.9. And then I'm going to divide by 4 over pi. So let me see. Count a little time. Throw this out. So 9 times 12.9. 116.1 over 4 pi equal to the radius. Now, here's where we got to be careful. I'm going to take that answer and I'm going to divide by 4 and pi. Now, I think the way I'm putting this in is going to work out incorrectly. It's going to be wrong. This should be wrong. Pi is about 3.14, right? 4 times 3 is about 12 something. So 116.1 divided by 12 is 91. The radius is 91 inches long. Okay, that's where my answer needs to make common sense. One of the things about using, and again, it depends upon your addition of a calculator. This ancient piece of equipment, the way I typed it in, it took that answer 116.1, and then I hit divide, and then I hit pi, and then or 4, and then I hit pi. But what it did is it went 116.1 divided by 4 and then multiplied by pi. It didn't divide by the whole thing, 4 pi. It divided by the next number that goes in the denominator, the 4. The next number, it doesn't think it's in the denominator. It thinks it's times that next number, the pi. The only way for me to tell a calculator that it needs to be in the denominator, parentheses. What I should have done is I should have typed in 116.1 divided by parentheses 4 pi. Now that denominator is intact. So I've got 116.1 divided by parentheses 4 and pi, and close the parentheses, and we see the difference, 9.2389. 9.238, 94446. Now, rest of the direction, round to the nearest hundredth. The only way to know what the nearest hundredth is you have to know it's in the thousands place. Please do not round until the very end. I didn't put pi in there until the very end. If you put in your decimals too soon, I know students are lazy. They would have plugged in pi over here, they got a decimal over here times r. They're going to round to the nearest hundredth over here. So they're rounding to the nearest hundredth already, and then they're using smaller or less accurate numbers in the final analysis. At the very end, you have your exact values, the pi involved. Now I put in the pi. Now I've got the most accurate decimal that is there. And then to round to the nearest hundredth, I got to see the thousands. That 3 is going to round up to a 4, 9.24 inches. And when we kind of put this pieces together in our heads, what we talked about last week was this. No matter what size a circle is, one radian is when you take the length of the radius, you wrap it around the circle, so that's the same length, and that's the same length. It's all one radius long. And this is approximately 57.1 approximately degrees. Okay. Now, we were told in this problem, the central angle was 80 degrees, which is bigger than 57.1. So if it's bigger than 57.1, and 57.1 is about here. So my radius of 12.9 would only wrap about that far. The arc length was, what was the arc length? Arc length was 12.9, wasn't it? Got mixed up. My radius is 9.24. So this would be 1 radian right here, 1 radian, 9.24. That's as far as it would go. The arc length we were given was bigger than that, because it was 80 degrees, 12.9. So it makes sense, 80 degrees, we better get something bigger than 57, bigger than 1 radian, because we got, or we have, an arc length that's bigger than our radius. Or in this case, we better get a radius that is smaller than the length of the arc. If it's 80 degrees, then the radius better be shorter than the arc length in order to get to 80 degrees and match up with it. It's got to be more than 1 radian. Okay. All these little things, if you just think through them. When you do a problem, instead of just writing down a crazy answer, think it through. Oh yeah, it makes sense. Or if you got, like the first time I did it, 91 inches as a radius, I can't do that. Okay. Can't do it. Not you. Not you. One more. And we were about to do degrees, minutes, and seconds. Conversions. So 29, right? Well, 937. I did 31. And let's do 33. 125 degrees, negative 125 degrees 36 seconds. So we're in degrees, minutes, and seconds, DMS, and we want to convert it into decimal degrees. Now, I will show you on the calculator how we can do that. First of all, just remember your answer is going to be negative. And basically, this is your whole number of degrees. This is your whole. You have a whole number of negative 125 degrees. Well, technically the degree would come after the decimal part, so hang on. You have a whole number of degrees, 125 negative. And then this is going to be the decimal part, because that's a less than a whole degree. Now that's 36 seconds. They just did a crappy job. This is usually not how it's written. Because the first thing someone's going to assume is that's going to be in the minutes place. Because it's right after the degrees. Typically, it is written like this. Negative 125 degrees, 00 minutes, and 36 seconds. That's how it's usually presented, so there's no mistaking that you have 0 in the minutes place. And you don't get them confused. But how we would convert it without a calculator is, this is negative 125. There are 60 minutes in every 1 degree, so you're going to add 0, basically 0, out of 60 minutes. And then plus, we have 36 seconds of a whole degree. There are 60 minutes in a degree, and there's 60 seconds in every minute. So 1 degree converted into seconds. 60 minutes in every 1 degree, degrees reduced. And then there's 60 seconds in every 1 minute. And now the minutes reduce. So 60 times 60, that's 3,600 seconds for a single degree. Not another 60. You don't divide by 60 again. It's not 360. 3,600 to get that decimal place. And the mistake people make is just divide by 60 again. Okay. So if I just do on my happy go calculator, I just need the decimal. So 36 divided by 3,600 equals, that's 0.01. I mean, think about it, it's 36 over 3,600. That's goes in 1/100th of a time. So this would be negative 125. And then my decimal would be 0.01 degrees. Oh yeah, we don't need that. Calculator does all. I have degrees, minutes, and seconds. That's what I want to convert. So, 125. Now I know it's going to be negative. So just don't worry about putting the negative. You know it's going to be negative. If you can, avoid pressing the negative button and just writing down that it's going to be a negative, you're going to be better off. Because a lot of times people will press this instead of the negative, And when you press this in front of a number, it doesn't work. When you subtract, that's fine, but if you start with like negative x and put minus x instead, you're going to get an error. So, right here, angle, where it says apps, in blue above it, it says angle. So I have 125, and I want the degree symbol. So I got to go to the apps, and I hit angle, and number 1 is the degree symbol. 125 degrees. Now I want 36 seconds. So I get 36. I go to app, or second and then app, go to angle. And then you can see right here, minutes, because it's just 1. And then R for, oh, that's radians. Oh, no. Seconds, it doesn't have the double. Oh, lucky me, they put it somewhere else. It is on the plus. Right here on the plus in green is the quotation, which is the seconds symbol. To activate the green, you got to hit alpha. So I'm going to go back to the home screen. And I want alpha and then my seconds. There we go. And then I just hit enter. Oops. Uh-oh. Let me do wrong. I wonder if they want me to put 0, 0. Let's do that. 0, 0, and then we'll do minutes. And 36. See, the calculator didn't like that I didn't have 0, 0 minutes in there. Because it didn't know what to do. Little version. That was the best thing about watching the Flintstones as a kid growing up, because they were predicting the future. Like, Polaroid camera, you take a picture, but there's a little bird there chipping away on a rock, making a picture. That was good stuff. So that's how you can work. And then don't forget to output negative 125.01 degrees. So that's how we do 29 and 33. And then 37, you're supposed to find the difference. What operation is difference? Subtraction. You're supposed to subtract. So let's do, which one do I like? I like number 36, so that will help you do number 37. As you can see, it does not say on a calculator. This is where you get down and kiss the ground and say, I am so glad we work in base 10. So find the difference. So which one do I write first? The first one is second. Because it matters. 5 minus 2 is not the same as 2 minus 5. So when it says, whenever you hear the words, find the difference between A and B. Is it A minus B or is it B minus A? A minus, just left to right. Whichever one is first, that's what you're going to subtract from. So it says find the difference of the angles. So this one minus that one. It's not about bigger minus smaller. It's about who's first and then what comes second. Find the difference between. So the first one minus the second one. When it's written, when it is written in that wording, okay? Language and translation. So now this is what you don't want. 120 degrees, 45 seconds, 45 minutes, 21 seconds, minus 12 degrees, 36 minutes, 3 seconds. You don't want that. Okay, and the reason why is because I don't know what I'm subtracting from what. When you have multiple places, multiple digits, and you're subtracting, you write it vertically most of the time. I know you use calculator, but you write it vertically. 120 degrees, 45 minutes, 29 seconds, minus, now places matter, 12 degrees. So 10's place, 1's place, 36 minutes, 36 minutes. That's 3 seconds. Okay, 3 seconds. So that technically should have been written 0.3 seconds. That's what should have been written. Now we go back to the third grade. 3 from 9 is 6 in the second place. 2 minus 0, that's 2. 29 seconds minus 3 seconds is 26 seconds. Take a victory lap. And then, 6 from 5. You can't take 6 from 5, so you got to borrow. So that's 5 minutes. That's 45 minutes. So we're going to borrow one of those, and that becomes 3, and that becomes 15. 15 minus 6, that's 9. And 3 minus 3, that's a 0. 45 minutes minus 36 minutes is 9 minutes. What's that? And technically, back out on the degrees, the whole degrees, 120 minus 12 is going to be 108. Can't take 2 from 0, so you borrow. That's a 1. This is now 10. 10 minus 2 is 8 in the first place. In the 1's place for the degrees. 1 minus 1 is 0, but don't forget to bring down that 1 right there. Okay. 38. Because I'm not going to just let give you that. 38. Hmm. 36 degrees. 8 minutes, so 8 minutes. 43 seconds. Minus 81 degrees. 17 seconds, so 0 minutes, 17 seconds. Now, here I'm taking something bigger away from something smaller. My brain does not do that very well. Because when you do that, you're supposed to do borrow, and you're not going to have enough to borrow. But I do know that when you take a bigger number away from a smaller number, you are going to get a negative answer. So I know that this answer is going to be a negative something. But you know what? It's just the negative. It's just the opposite if I flip it. 2 minus 5 is just the opposite of 5 minus a 2. 5 minus 2 inside here is positive 3. And the opposite of positive 3 is negative 3. That's what 2 minus 5 is. So if I can't figure out what 2 minus 5 is, I take 5 minus 2 and then just change my sign, make it negative. So what I'm going to do is I'm going to rewrite this. And then do white. So we have another white space here. We'll trade places, and I just know my answer won't be next. 81 degrees, 00 minutes, 17 seconds, minus 36 degrees, 8 minutes, 43 seconds. Okay. In the seconds themselves, they are base 10. Yeah, but it only goes up to 60. It only goes up to 60. Same thing for minutes. It's base 10. But it only goes up to 60. If you get 61 minutes, then 61 minutes, you would not be able to write 61 minutes because that's 1 degree with 1 minute left over. If you're going to write degrees, minutes, and seconds, you never put 61 minutes because on a clock, you don't have 61 minutes. Once you get to 60 minutes, the next hour starts. Once you get to 60 minutes in an angle, the next degree starts. Same thing with seconds. Once you get to 60 seconds, the next minute starts. So these two columns are base 60. And then the degrees themselves are base 10. So you got to do a little bit of thinking as you do this. 7 minus 3, that's a 4. That's no big deal. In the second place. And then 4 from 1 we can't do. So you borrow. You got to borrow. So I go next door over here to borrow from the minutes place, and they have nothing to lend me. So I can't borrow anything here. So then I got to go all the way over here and take away one of these degrees. So now I'm going to take away a degree. Now I have to 80 degrees. I took 1 degree. That 1 degree is now 60 minutes in the minutes place. Right? So now I have something to borrow over here. I'm going to borrow 1 minute. So this is no longer 60 minutes, it's now 59 minutes because I'm borrowing 1 minute, and I'm going to convert that 1 minute into 60 seconds. I have 1 second, so this is now 70 seconds. I borrowed 1 minute, which is 60 seconds, to combine with my 10 seconds that I already have in the 10th place. So 10 seconds and the 60 seconds that I borrowed is now 70 seconds, or a 7 in the 10th place for the seconds. Okay. Technically, it would have been 77 total seconds to be able to do anything. But I didn't have to on the 7 and 3 because I was okay. Who knows? I might be all the way okay all the way across. Right? I crossed the bridge when I got to it. So one more time. I couldn't borrow from the 0. I couldn't borrow from that 0. I had to go all the way over here. I borrowed 1 degree and I converted it into 60 minutes. Now I can borrow over to the second place. So I take 1 of the minutes. So now I only have 59 minutes. I took 1 minute, converted that minute into 60 seconds to combine with that 10, that 1 in the 10th place. So the 6 and the 1 make a 7 in the 10th place. So now I've got that 7 minus that 4 is a 3, 34 seconds. Now over here, I got a 9 minus 8 in the minute, so that's a 1 and a 5 minus 0, so it's a 5 at 51 minutes. And then you can't take 6 from 0, so you have borrow, that's a 7 and a 10. 10 minus 6, that's a 4 in the degree spot. 7 minus 3, that's a 4. And don't forget it's negative. Negative 44 degrees, 51 minutes, 34 seconds. Now, calculator do this? Sure. You better make sure you punch everything in right. So I'm going to punch in as is, 36. I need the degrees, so there's a lot of things to punch in. Degrees. 0.8 minutes. 20 minutes. And then 43 seconds. Yep. And then minus 81 degrees. Zero, 0.07 minutes. And 17 seconds. It gave me decimals. Oh, that's the next kind of question. So I'm going to show you how to do the next kind of question. Convert decimals into DMS. So let's start with this. So I've got, well, good thing I have 44, that's a negative 44. But that decimal part should be 51 minutes, 34 seconds. Okay. Supposed to be negative 44 degrees, 51 minutes, and 34 seconds. Now to get decimal degrees into DMS. So you need whole degrees. Your whole degrees, negative 44. You just take that. I bet. I have to do this. Wait a minute. Oh my God. It's like I have this, I have that, I want that to go to this. Decimal degrees into DMS. Negative 44.85944. Negative 44, negative 44 degrees. So that's my whole degree, that's my whole degree. The next part is my minutes. What are the minutes made of? The minutes are made of what this decimal is. It's the decimal portion of my whole degree. So what I do here is I'm going to take this 0.859 444 times how many seconds in 1 minute? Sorry, how many minutes in 1 degree? That's where I get tongue-tied when I do this. I say seconds when I need minutes. 60 times 60. I need minutes. So this decimal is how many, the fraction of a degree. This is my fraction of the degree. So times 60 minutes. And so I'm going to get negative 44 degrees, and I'm going to have minutes right here. And I'll put it on this other calculator. Whoa, what happened? pointing up at the ceiling. There's a calculator. Oh, little just plain old simple scientific. So I'm taking this decimal times 60, and this is what I get. Never mind. Just the decimal Esquivel, 0.859 times 60. Okay. So this is what I get right here. I get 51 degrees, or I get 51.56666664 minutes. That's what I get in the minute spot. The leftover decimal, and that's how many minutes I have. But you don't get to put decimals when you do DMS, no decimals. How many whole minutes? Negative 44 degrees, and exactly 51 minutes right there.
And you use them for the person that they're correct.
Correct. So now, and this is what I know confuses people about the 3600 going in one way, divide by 3600 when you convert it. My seconds, this is the decimal of a minute. So this decimal of the minute is what you use to make your seconds now. So you're going to take this 0.56666664, and there are 60 seconds in 1 minute. So that decimal on the minutes, that leftover decimal part, is what's going to make the seconds. So you multiply by 60 seconds. Well, we did 3,600 the last time. Well, technically, we already multiplied by 60 once. And now we're multiplying by 60 again, 260, that is where the 3,600 would have happened. But again, we're also converting from minutes to seconds. When you go the other way, we're taking the seconds straight to degrees. So times 60. And this is negative 44 degrees, 51 minutes, and I get 33.999984 seconds. And so I'm sure we're going to round to the nearest second, because you don't put decimals when you do DMS. So negative 44 degrees, 51 minutes, and 33.999 is going around to 34 seconds. Now, that's what you would have to do if you were living with me and my age in this thing. All I got to do is take that answer. And how do I take that answer? I go second and hit the negative sign, which has A and S right above it. That means it's going to copy the answer on the next line. So you don't have to type in that whole thing. I hit second. There's something wrong with my Wi-Fi. So second, and I hit
Enter. I didn't mean it. Second answer. And then back to angle. And then option number 4. Basically something before it, and then an arrow pointing towards DMS, degrees, minutes, seconds. So it's going to take my answer before the DMS and it's going to convert it into the DMS. So, and I hit that. Man. Yeah. Okay. So that's how you convert these decimals. Just punch in your decimal degrees and then hit second, angle, and then that option, angle into DMS, and then hit enter and we'll convert for you. Okay. You don't have to put the negative when you do it on the calculator, just make sure you put a negative in front of the answer. Any questions? I want to show you that the calculator doesn't have to do it for you. At some point, you never know when you're not allowed to use a calculator. I don't know what it's like now, but I know when I was teaching high school, UCs and most Cal States banned calculators in their calculus classes. You had to do everything pencil and paper, long division, multiplication, additions, everything, decimals. Because a graphing calculator does way too much these days. And you can, if you know how to work it, you can get, and you can store formulas in a graphing calculator. I had students that were playing video games, playing Donkey Kong on their TI-83s. Just download the programs. I know you're not doing math if you're using your calculator like this. So you do need to be able to figure some things out in order to survive. I don't know what the connection to the universities is. I have to ask Mr. Candiari if he has it. Okay, so 39 to 59 every other odds. That's how you do 9. Complements and supplements. So complement we talked about, they add up to 90. Supplement, they add up to 180. Talk about those. 39, 43, 47, you're skipping 49, 51. Okay. Determine the quadrant in which each angle lies. The measure is given in radians. So this is where we start to fill in our unit circle. And well, we started already, but here's where we start to make some necessary additions to our unit circle. Okay. And here's what you know. 0 degrees, 180 degrees, then back to 360 degrees. And then we cut it a half, we have 90 degrees and 270 degrees. And then we cut those into halves. So half of 90, here's our 45 angles, 45 degrees. And then 45 here, 135 degrees. 45 in between here and here is 225 degrees. And between here and here is 315 degrees. And the next most important angle we talked about was our 30s and our 60s. And if you have your 30s, you got your 60s. So 30 plus 30 is 90. Oops. Plus 30 is 60. So plus 30 is 90. Plus 30 is 120. Plus 30 is 150. 30 is 180. Plus 30 is 210. 30 is 240. 270, 300, and 330 degrees, and then right to 360. Okay. Does anybody need a copy of this to want to do it right now? I gave you lots of copies. If you want one right now, I got one. Okay. So, great. So that's a little bit of problem. Try not to memorize. Calls for something special. We got pink and purple. We got brown. Got some crazy version of a light blue that I think is done, but we'll try it anyway. The highlight, no, the highlight. So we know the full circle is 2 pi radians. So 0 degrees is the same as 0 in radians. And a full circle is the same as 2 pi radians. So halfway, 180 is the same as pi radians. Pi in radians. So if you open up an angle to 180, you're opening up an angle in pi radians, radian. So now the 90. 90 is halfway to 180. It's half of 180. So 90 is 1/2 of pi. It's that direct. If 90 degrees is half of 180, then exactly at 90 degrees, this is pi over 2 in radians. Halfway of 90. Now let's count by halves. 1/2 of pi. This is 2 halves. 2 over 2 is 1 pi. This would be 3 halves. So 3 pi over 2 in radians. And this would be 4 over 2. 4 over 2 is 2 pi. Right back to 0. Okay. Then we took our halves and we cut them in half again. So at 45 degrees, it's half of 90. So at 45 degrees, we're going to take 1/2 of pi over 2. 1/2 of 90 degrees. 1 over 2 times pi over 2 is pi over 4. This is pi over 4 in radians. It's 1/4 of pi. 1/4 pi. So now we just count by 1/4, count by quarters. 1 over 4 pi. This is 2 over 4. 2 over 4 is 1/2. At 135, 1/4, 2/4, this is 3 pi over 4 radians. At 180, 3 over 4 plus 1 over 4, that's 4 over 4. 4 over 4 is 1 pi. Four over 4 plus 1 over 4 at 225, this is 5 pi over 4. Five over 4 plus 1 more is 6 over 4. 6 over 4 is the same as 3 over 2. It's 3 over 2 pi. 6 over 4 plus 1 over 4 is 7 over 4. 7 pi over 4 radians. And then it's 7 pi over 4 plus 1 more pi over 4 is 8 over 4. 8 over 4 is 2. 2 pi when you get back to 0. It's nice when fractions behave. 30. All about what one do we know the most? Pi and 1/8. 30 out of 180. 30 goes into 30 once, 30 goes 6 times. 30 degrees is 1/6 of 180. Because it's cutting it up into 6 equal pieces. 30, and then there's another 30, and there's another 30. In 90, you have 3 30-degree angles. One 30 degree. Then right here is another extra 30 degrees, and then you have 30 degrees right here. So there's 3 30s in a 90, so there must be 6 of them in 180. If there's 6 in 180 at 30, this would be 1/6 of a pi, pi over 6. And then 60, that's 2 30s. Well, 2 of those pi over 6s, 2 of those pi over 6s, well, 2 goes into 6 3 times, is pi over 3. This is pi over 3 in radians. That's 60 degrees. And also, when you think about it, from 0 to 180, you have 60 degrees. And then you have another 60 degrees to 120. And then you have another 60 degrees to 180. You have 3 60-degree angles that make up 180. So 60 is 1/3, really. 1/3 of 180, so it's 1/3 of pi. So we have 1 over 6, that's 2 over 6. This is 3 over 6. 3 over 6 is pi over 2. This would be 4 over 6. 4 over 6. Well, 4 6, that's 2/3. 2 pi over 3. Because isn't 120, isn't it 2 60-degree angles? So that would be, and 60 is 1/3, so it's 2 of those pi over 3s. 2 pi over 3. So this was 4 of those 6. This would be 5 of them. 5 pi over 6. And then here is, and this would be 6 over 6, which is 1. Going over the 30, which is another pi over 6. So 6 over 6 plus 1 pi over 6. This would be 7 pi over 6 radians at 100, 210. And then another pi over 6 is 8 over 6. 8 over 6 would be 4 pi over 3. Because when you get to 240, that's 4 60-degree angles. And every 60-degree angle is 1/3 of a pi. So 4 of those 1/3 pi's. So 4 of those pi over 3's. 4 pi over 3. So 8/6, and another one is 9/6. Well, 9 divided by 6 is also 3/2, 3 pi over 2. 9/6 plus 1/6 is 10/6. And 2 goes into 10 5 times, 2 goes into 6 3 times. That's 5 of those thirds. Or 300 is another 60 degrees from 240. So it's another pi over 3, 5 pi over 3 degrees. Ten over 6 plus 1 more over 6 takes us to 11 pi over 6. And then 11/6 plus 1 more will be 12/6, and 12/6 is 2 pi. And if you notice, the amount of opening going in this direction is pi over 6. 1/6 of pi. If you're here and you go in this direction, 11 pi over 6 right here, well, that would be, well, if you think about it, 0 minus a pi over 6, so negative pi over 6 in that direction. The amount of opening from the central angle is going to be the same in either direction, because that's where 30 degrees goes up and 30 degrees go down. So the positive and the negative angle is going to be the same whether you're in degrees or you're in radians. Direction matters. So here on the homework, when you do 51, what quadrant would 1/6 of a pi? Quadrant 1. Definitely now that you see it, but if you didn't see it before, 1/6 pi over 6 is 1/6 of a pi. And if you know that 180 is a full pi, 1/6, if you slice it into 6 equal pieces, then 1/6 wouldn't get that far. It would be in quadrant 1. That's more or less what they're hoping you see. 5 pi over 4. Hopefully you're recognizing that at 5 pi over 4, 5 is more than a 4. And because it's more than a 4, 5 over 4 is more than 1 pi. It's bigger than this. It's more than 1 pi. Not a whole lot more. It's 1/4 of a pi more. Now, to go past here, you have to have a pi over 2 to get past that. To go past 271. You only have an extra 1/4. So it's only going to carry you into quadrant 3. Five pi over 6. Well, 5/6 is almost 1. It's less than a 1, but it's almost 1. It's really close. It's 1/6 short of 1. 1/6 short of 1. But here's 1 pi. You go like this. So you're just going to be a little bit short. You're in quadrant 2. Oh, sorry, that's 52. Okay. Did you get the picture? You don't have to have seen all the units circle with all the radians and degrees at the same time. Reason, but I understand what it's like. I've never seen this before. I don't know what they're even talking about. That's what they're talking about. Making that connection. All the way to 59. So 59, they want you to sketch the angle in standard position. You got a negative to work with, so you got to open clockwise. -7 pi over 4. Now, 7 of those 1/4. I'll look at that as 7 of those quarter pies. I know a quarter of a pi is 45 degrees. But it's negative, so I got to go this way. So there's 1/4 That's 2/4, there's 3/4, there's 4/4, 5/4, 6/4. Right here would be an angle that is -7 pi/4. So if I'm going to sketch it, it would look like and you have to have that spiral to show the direction that I opened, and labeling it always helps. And then that second question was -5 pi/2. I don't even see 5 pi/2 on my graph. What's that going to do? Yeah, almost, yeah. It's going to have to go around. It's 5 divided by 2 is 2.5. 2.5 pi. 2 pi is 1 revolution. This is an extra, keep going past. Hey,
Mr. Escobar?
yes, sir.
Can you talk to me?
I don't think. Yeah, for some reason, I thought you were like, so you're just doing, you're only,
103.
the 103, but that's where you're only the, embedded, right? Okay.
I'll try to talk to Sam and get the classes.
Right, but you are able to help if somebody just pops up and says, hey.
Yeah, I 17 hours, you know, 17 hours for those student classes too.
Okay, yeah.
Yeah.
Okay. Thank you, man.
Thank you.
-5 pi/2. So there's -1/2, -2/2, -3/2, -4/2, -5/2. And it's okay to count. Okay, that's how you know you got it right. You can high five yourself. Sometimes it's the one person that will high five me is myself. (63 to 119 odd). Rewriting each angle in radian measure as a multiple of pi. Do not use a calculator. Okay. Hello, unit circle. And 315 was part of our warm up. That's even anyway. Okay, how about 65A, 18 degrees? 18 degrees is not one of our special angles. We want radians in terms of pi. That's the way we roll. Exact value, 18 degrees, and over here we want radians. So you want to get rid of degrees, so you're going to have to divide by degrees and multiply by radians. The conversion, there's pi radians in every 180 degrees. So you're multiplying by pi over 180. That way your degrees reduce, and you want the radians only. And 18 goes into 18 once, it goes into 180 10 times. So pi over 10. Exact radians. 18 is 1/10 of 180, so it's 1/10 of pi. And then 67, convert to exact degrees. So let's do 6980. So We want exact radians, or sorry, exact degrees. A 7 pi over 3, that's radians. It's negative 13 over 60 pi. We don't want radians, we want exact degrees. All right. So that means we want radians to reduce. I know the word that everybody wants to just cancel. But I was told, like, before I even started working, when I was an adjunct teacher back in like 2000. There's a math teacher out here. When you say the word cancel, oh, he gets upset. He gets really upset. Because when you have fractions, they don't cancel, they reduce. Well, the time you cancel 5 plus a negative 5, they cancel out. Mathematically speaking. So it's like embedded in my mind is, don't say the word cancel. Technically, he's right, but technically, yeah, maybe too much caffeine. I don't know. I know I get obsessive. I want to undo radians. We got to divide by radians down here. We'll find the degrees up there. And the conversion is there's 180 degrees in pi radians. That's what's going to do it. The radians reduce. And even pi reduces. 3 goes into 180 60 times. So you're left with 7 times 60, which is 400. Wow, that keeps popping up. I'm not trying to tell you anything. So you can remember my birthday. It's my birthday. When, yeah, I know I have to. Because that number pops up, it's like like drawn to it. Because it's got more meaning than my birthday. Nobody cares about my birthday. It doesn't. They care about whatever else happens. Like Hitler was born. And Columbine. Which, why you probably want to do that other thing on that. Yeah, I don't know what that is. It's also George Takei's birthday, who played Sulu in the original Star Trek, and Carmen Electra. But whenever I'm supposed to give my birthday, I will always say April 20th. I can't bring myself to, oh yeah, 420. Because my birthday is early. Yeah. If they put it together and look at me weird, that's when I know. All right. But that's how we get there. Same thing here. Now, also, isn't 7 over 3 more than 2 pi? So shouldn't that answer be more than 360? If you don't get something bigger than 360, there's something wrong. This one is less than 1 pi, definitely. So I'm going to get less something negative. Obviously, don't forget the negative. Okay. We got degrees. Undo the radians. So it's pi radians into 180 degrees on the top. Radians reduce, the pi reduces. 60 goes into 180 3 times. So negative 13 times 3 is negative 39. And you have nothing left in the drawing. The 39 degrees. So you're looking at this one. That can't be an exact, can't we? Yeah, it's an exact negative 39 degrees. Okay, so that's the example there. Okay, now on a calculator, convert to decimal radians, and then we're going to convert to decimal degrees, 3 places. $73
73 is negative 216.35 degrees. And let's do 77 and 82. 77, which is pi over 7, 42, which is a negative 0.57. I'm gonna have to say goodbye. Okay. So the first one we have is degrees and we want radians. So my calculator right now, if I go and check the mode, I am in degree mode. So that means when I punch stuff in, it's going to be in degrees. If I leave it like that, let's just see what happens. So I'm going to punch in, and again, I'm not going to punch in negatives. And X is going to convert. This is degrees on radians. Negative. So 216.35. I'm going to hit the degree symbol. Option 1. And I want to convert that into radians. And right there. Enter. It's in degrees. Watch. If I actually put my mode in radians, and type in what I have again, I have to put the degrees in 216.5 degrees. I'll do that. Insert. 3. Move over. So all I have is I typed it in as degrees, but my calculator is in radian mode. So if I type it in as degrees, I just hit that. It converted it to radians 1. I don't have to press anything special. But if I want radians, then the mode should be in radians. And if I type in degrees, it's going to convert the degrees into radians just by hitting enter. So negative 3.776019.837 radians, and the direction said round to 3 decimal places. So we should have negative 3.776 in radians. Now, mental check. Are we close? Is it right? Is it not right? How many degrees is pi? No, how many degrees is pi radians? Pi radians. 180. Pi radian 180. That's more than 180, isn't it? What is pi as a decimal?
approximately. 3.14. So if this is more than 180, it's more than pi radians. And if it's more than pi radians, it better be more than 3.14. Now, it's not even 225 is where you get 5 pi over 4. 225 degrees. That's 1/4 of the way through the third quadrant. This is 225. So 216, and I'm going to pause it because it's easier to see. 216 is right about here. You're not going that much further. So it's not going to be huge. It's going to be really big past 3.14. But it better be bigger than 3.14 as a number. Make sense? And then radians, we want decimal degrees. Or we want degrees. So now I'm going to put my calculator back into degree mode. Back into degrees. Enter. And then I'm going to press in pi over 7. So pi divided by 7. But I have to tell it I have radians. So I go back to angle. And the symbol for radians is number 3 right there. So that's pi over 7 in radians. And because I'm in degree mode, I'll just hit enter. Parentheses. Over 7. I didn't put in parentheses. Parentheses matter. It took the number pi and divided by 7 whole radians and converted the 7 whole radians into a total number of degrees. Now 7 whole radians, 1 full revolution is 360. That's 6.28 radians. So 7 whole radians is more than 6.28. So 7 whole radians is a number bigger than 360. So it took pi and divided by a number bigger than 360. That's why it's this small. because it was only converting the 7 into radians, sorry, into degrees. Now I'm taking pi over 7 as a whole thing, as now that's my radian measurement, that's my R. Hit enter because I'm in degree mode, and it converts it into 25 point, round to 3 decimal places, 0.714 in degrees. Which makes sense because pi over 6 is 30 degrees. Pi over 7 is smaller than 1/6. So therefore, it should just be a little bit smaller than 30 degrees. Okay. Parentheses. Gonna bite you every time. Okay, and then I want to do 81 here. So at 81, no, 82 for no. 81 and then 82 is our example. Is a little perplexing to some people because they forget most of the time we have pi when we're talking about radians. Pi is involved somehow. It's always something of pi. But 81 and 82 ain't got no pi's. And so we forget that it's radians. It's still radians. You can have 1 radian, 2 radians, 3 radians. Okay, just that's the length of the radius wrapped around exactly. This is how many degrees is exactly -2 radians. Well, 1 radian is about 57 point something degrees. So 2 of them would be twice as big in the negative direction. So that's what you would do, but you're going to convert on the calculator anyway. This time, there's no pi when you punch it in. So I'm going to punch in parentheses -0.57. I'll make a little radius, radian, and then I'm just going to hit enter. And it's going to convert it into my degrees. Okay. 7. The negative, put my negative in. Option 3. And approximately -32.65859.432 degrees. 3 decimal places, the 5 rounds up to 9, -32.659 degrees. I'm not going to get a chance to do any lecturing. That's okay. I'm okay with that. I know that's where I usually end up. Because I know it may feel like I'm holding your hand as we go through this stuff. I don't mind as we get going because the way these things are worded, I can just say, hey, figure it out, or I can do my job. I feel like I need to do my job. Make sure you at least complete through 81. If you can keep going, but on Wednesday, we are going to start, we will finish going over these. I love these last few questions, the word problems. They hit me in the hat, which is good news for you. All right, me, I got the roll of it. Also, what I think on Wednesday, what I'm going to do is I'll do another practice quiz, not the beginning, but I'll send it home with you. And I can post the answers on Canvas and we'll use that, as a warm up on Monday before your quiz Monday at the end of class. All right, Roger. Josh, say hi.
Yes.
All right. Pablo. Marcelino. Brett. Lindsay. Brennan.
Here.
Daniela. I'm gonna say it. Isaiah.
Here.
Candace. And Christopher is not. Okay, have a good one, you guys.